needs to be done on a big, wait, am I still taping here? Yes, okay. Write down this here problem. Wait, what did I say this was called? Similar triangle. Story problem. This kind of stuff you will find on most math tests, even when you try to get into colleges. But it's not hard. You just have to figure out. Set it up here. Bob wants to know the height of a flagpole. Bob wants to know the height of a flagpole. What would be the problem with trying to figure out the height of a flagpole?
Can't reach.
Yeah, you can't reach the top of it. You couldn't even really get a ladder up there because it's pretty tough to put a ladder on a pole. Now, if you had a boom truck or something like that, or knew somebody that had something that, you know, a lift or something, but yes, but you don't have to like borrow that just to figure out how tall your flagpole is. So, Bob, boom, 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 boom. Bob sticks a meter stick in the ground. Sticks a meter stick in the ground. Oh, why doesn't I put it in the ground? And finds the length of its shadow. And finds that the length of the stick's shadow is 120 centimeters. At the same time, comma, the shadow of the flagpole is 30 meters long. How tall is said flagpole? How many gone today, by the way?
Tyler and Karen.
Are they sick?
I think it's Tyler's. Thank you.
Give you a chance to finish writing that problem, and then we talk about it. All right. The first thing you will do, and this is undoubtedly the most important part of this, is you need to sketch that out, exactly what it says. So you're going to draw your picture. First of all, the guy stands a meter stick in the ground. By the way, how tall? And he finds out that, here's the deal. See, the sun does an unusual thing. Because of its brightness, it casts a shadow. When this stick is here, the shadow, it casts this long shadow of that stick. What are the dimensions that I know of this? Well, first of all, how tall is a meter stick?
100 centimeters.
Now, why do I pick 100 centimeters? Mostly because they give this dimension in centimeters as well. How long was the shadow? 120 centimeters, right? And then here's the rate of the shadow. We don't know how long it is, nor does it really even matter. Okay. So here's my meter stick shadow. Now I've got Mr. Flagpole. Flagpoles stand vertically in the ground as well. Usually there's a little bubble up there. Maybe there's a flag on it. Okay. We don't know how tall it is, but we know that it casts a shadow how long?
30 meters.
30 meters. And again, same sun shining, same thing, cast that shadow that's that long there. Now, what you must recognize is that these two are similar triangles. How do I know that? Well, because when you put something vertically in the ground, it makes a right angle. And the sun is coming in at the same angle with it. So these angles, the sun's so far away, it probably does maybe come in at just a small different angle, but it's so far away that it doesn't matter. These angles are similar, and these angles are similar. So there's your sketching of this, righto? So that's step number one. Step number two then is to make a table or a ratio box. And I will show you exactly how to label it. That means you have this. What are we comparing? We are comparing the smaller triangle to the big triangle. Small to big. And what are the other two things we're comparing? We're comparing their height to the length of the shadow. I just need to fill in those numbers and solve. How tall is the small triangle? Right here, it's 100 centimeters. How long was the shadow on the small one? 120. How tall is the flagpole? We don't know, but we do know its shadow is 30 meters. Now you don't really have to change those into centimeters because this will all end up being, this side will all be in meters and this will be in centimeters. Now, how do I solve that? What's the easiest way? Abram?
Multiplying 30 and 100 and then dividing 120.
Well, that wouldn't be the easiest way, although that's the way that always works. Here's what you're looking at. You have 100 over 120 equaling some number over 30. Right? Anybody, easier way than doing that. What Abram said is you can multiply 30 times 100 divided by 120. You will get the answer there, but there's a quicker, easier, simpler way. That Amelia?
Divide 120 by 30.
Yeah, you can figure out this. Well, how do you go from 120 to 30? Divide by what? Divide by 4, right? So you can take 100 divided by 4, and guess what you get?
Answer.
25. Your flagpole is 25 meters tall. The other thing is you could reduce this. What number goes into 10 and 12? Or 112, 120, sorry. 10, and then it's 10 12, so what goes into 10 and 12? 2, you end up with 5 over 6, and then you can say 6 times 5 is 30, 5 times 5 is 25. So on your paper, I mean, you don't have to write out the words of the problem, but I definitely need to see this. If you're given this story problem, don't worry, it'll come back. You need to sketch out these triangles and make that ratio box. Definitely. Let's try another one here. Oh yeah, look at page 443 for me, because I don't want to sit there and write this whole thing down. Look at example letter B. They actually draw the thing out that you'll sketch on your paper. It says, holding a ruler upright at arm's distance, like this. At arm's distance, Ronnie aligned the bottom of the ruler with the mark on the utility pole that was about 5 feet above the ground. He saw the top of the pole aligned with the 6-inch mark on the ruler. Then he took 40 long strides to reach the pole. If each stride was about 1 yard, the top of the pole is about how many feet high? Now there's a lot of words there, is there not? But I can guarantee you, if you sketch it out, you will see it all kind of come into play here. So first of all, the guy holds out his arm. Here's his arm, right? At the end of his arm, what does he have? A ruler. How tall is the ruler?
6 When you're-
12 inches?
6 inches or that's 12 inches.
What does it say?
24 inches. 24 inches.
No, arm's distance is 24 inches. Here's his arm. He's holding the ruler up there. This is 24 inches. You say he holds a foot ruler up there, doesn't he? Yeah. Ronnie, line the bottom of a ruler with the mark. Does it say it's a ruler's?
It doesn't
Building a
look like
ruler.
the
Bottom of a ruler with a mark. I'm guessing. Oh, well, it doesn't matter because it doesn't matter what the ruler is. Later it tells you this. I can't put 12 there. He then aligns this with a utility pole. Here's my utility pole. And this is, it says with a line that's 5 feet up. Okay. And then he does this, please. It says at the 6-inch mark, let's call this the 6-inch mark there. Okay, he lines that up. Was that with the top of the pole? It is the top of the pole. I missed it. Hold on a second. Here's the top of the pole. And here's my ruler. Here's his eye. Some eyelashes. How tall was the ruler? He said it lined it up with the 6-inch mark. Right? He said it lined up with the 6-inch mark. And then it said, how long was it from here to here? It said he took how many steps? 40 steps. And each step is what?
1 yard.
1 yard. So it's actually 40 yards, correct? Or 120 feet, it doesn't really matter. So what do my two triangles look like? Here is one of them. This little one right here is one of them. Okay, and that triangle looks like this. It is 24 inches by 6 inches. My other triangle starts here as well, but it's much larger. Okay, it is 120 feet. And I want to know this distance right here. But don't forget, that distance starts right here. You're going to have to add 5 feet onto it at the end because he says the mark is 5 feet up if you're looking for his total height. So again, you just make your ratio box. You've got small and big. You've got height and length, I guess you would call it. The small height is 6. The small length is 24. The big length is 120, and you're looking for this number here that you're going to, in the end, add 5 to get the total length. So again, rewrite it as a fraction. 6 over 24 equals x over 120. I would reduce this. What's that reduced to? 1 over 4, correct? 4 times what is 120? Somebody? 3D, 30. So 1 times 30 is 30. How tall is my flagpole?
35.
35, because that's the point here. He has to add 5 more feet to it. It's 35 feet tall. Which is a good way, if you're ever out there measuring stuff, you can kind of get a general idea, because you can always use the sun's shadow, you can always use rulers. Without actually getting out there and doing it, it's not a bad way to measure some stuff.